Hello, I'm John Furrier with theCUBE here in Seattle at the AWS headquarters at reInvent, getting all the action on reInvent news and all the big announcements on stage. Clare Liguori is here, Senior Principal Engineer at AWS. Talk about Strands, great to see you. Thanks for coming on theCUBE and special news analysis on stage and the big reveals. Thanks for coming on.
Thanks, happy to be here.
This is our 12th year covering reInvent, and every year is great, but this year seems a little bit more game-changing in the sense that the AI game is on, everyone sees it, it's the top line in all the boardrooms, all the engineers are working on it, people coming out of retirement because with coding assistants and Kiro, all the cool things, it's very easy to do stuff now at scale. Plus, the infrastructure investment is in line with the pace of the demand. So you're starting to see the formation of the agent software stack model. You're starting to see the formation of startups that are AI native. Now it was cloud native, they're still around, they're on the cloud, but cloud and AI native are kind of converging. And Strands is one of the most exciting things we've covered because it kind of grew organically here at AWS. And now it's like becoming the key linkage and coordination, connective tissue, whatever we call it, but with the models. So tell us why the news is so big.
Yeah, that's right. The Strands grew organically out of a need that we had in Amazon for a simple way to build agents. And we decided we had so much success with it internally that we decided to open source it for our customers. And to this reInvent, we are announcing two big expansions to that. One is TypeScript SDK support in addition to Python, and the other is support for edge runtimes with Strands.
And the uptake on the terms of the developers, what's been some of the stats? You guys had like millions of downloads. What was the number?
We've had over 3 million downloads of Strands since its release middle of the year.
Okay, so we're also hearing about the whole frontier models, Nova, opening up, democratizing. Frontier agents opens up a whole nother level of value because now you can take kind of the coolness of agents and make it operational with all the stability. How does the Strands fit into all this? Because how would someone think about Strands for, say, frontier agents?
We have a design philosophy, really two design philosophies. One is as easy as possible. We want you to write as little boilerplate code as possible, just a few lines of code to get started writing a real agent. The other is what we call the model-driven approach, which is instead of writing a lot of boilerplate and a lot of logic around the models, let the model do the driving. We found that models, frontier models especially, are so capable of reasoning and driving the tool selection and things like that in the agents that the more that you do almost around it, the worse your agent gets, is what we actually found internally. And so simplifying it and paring it back to as simple as possible in integration with the model means that you're able to take advantage of the full capabilities of the model. And then as the models are getting better, which we're seeing every few months, you don't have to do anything to your agent other than change which model you're using for your agent to suddenly get better. You don't have to change your entire software stack around it.
So that kind of brings up what we've been seeing, kind of the progression of how people have been playing with models. They go, oh, I grab this model, then they go down the road and the better model comes out, then they have to walk that back and then come in. You're kind of laying out this optionality play where you create software around models that may be available and you can almost pick the right model for certain use cases. Is that right? Am I getting that right?
That's right. You can think about cost, you can think about complexity of the tasks that you're doing, you can think about particular use cases that the model might be better at or not, and make that selection and change it down the road. Often I find what happens is that when we're prototyping an idea for a new agent, you pick the best model possible, right? You pick the absolute best of the best to just prototype and think through, is this even a feasible idea? And then you start to get thinking about production and cost and efficiency, and you start to optimize, but you don't have to change anything about your agent itself. It's just swapping out the model and seeing how it performs.
It's like that scene in The Matrix where you can just upload the best model for the task. I found What's the Matrix, if you've seen that movie. So maybe the younger generation might not have seen The Matrix, go check it out. But this brings up the model-driven approach. I do like this because we've been seeing it in some of our our observation space with the cube and SiliconANGLE, young startups, they're not thinking, where do I host the servers? They're thinking, how do I build within the models themselves? So they're optimizing for their end game, which is the app goal, which is the outcome. But they're using the models first and then writing code, distilling. And so with now you have Nova. So you have with that new approach, Nova with the open data. This is a different development innovation formula. How would you describe this? Because this kind of feels like very much the AI native side. Now, once they do that, they still got to run it on AWS or infrastructure. So how legit is that? Do you see the same thing? And how would you kind of frame this new trend?
One thing that we are starting to see is that thinking about development is very different with agents. So normal, traditional programming paradigms, you write a sequence of steps, and you might turn those into a workflow. There might be a loop somewhere or an if statement, condition somewhere. Agents are completely different because they have such reasoning capabilities. Often we're finding that for complex tasks in the past, when models weren't as capable, people would kind of go back to those same programming paradigms that they're familiar with, create a workflow. But as it turns out, that's a very brittle approach. You have to think about all the edge conditions. Your agent isn't flexible for unexpected use cases that might come in. And so we found that we were spending, when we did this inside Amazon, we were spending so much time trying to get these agents to do what we wanted them to do. And when we went back to the model-driven approach, we found that we can actually guide and steer the agent and let the model kind of come up with the workflow itself and still have the capability to do really complex tasks in the agent. So it's a very different mindset among younger companies, younger developers that are coming up in this sort of completely non-deterministic AI world, right?
And I think that's what's nice about this agent world is that there's a lot of value in that non-deterministic way because that's the goal of the AI, to be reasoning. You brought up the edge, and we'll get that in a second, but the TypeScript, you said it's one of the most popular languages, and you mentioned Python. Python, some would say, is the most popular. So talk about the difference between TypeScript and Python. Why agents like TypeScript over, say, Python?
Yeah, I'm really excited about TypeScript SDK being in preview for Strands because TypeScript is based on JavaScript, and the two combined are the most popular programming language ecosystem that there is. And so we're really broadening access to more and more developers who are used to working in TypeScript and JavaScript. But the other part of it is now the agents can run in new places. They can run in the browser. They can run anywhere that JavaScript can run, which is pretty much anywhere. And one of the things that I've noticed is that it's actually potentially a lot easier to write your agent because you get a lot of the nice characteristics like type safety and TypeScript that you don't get in Python. So you're actually able to almost build your agent faster because you get compile time errors and things like that versus Python, you may not know there's a problem until you actually run it.
So that's basically like letting it run out in the wild and then it breaks, you got to troubleshoot, so there's better safety.
That's
you're
right.
saying with
That's
TypeScript.
right. Yeah.
All right, let's talk about the edge, because the edge is something that you mentioned. We've been covering AI factories now for over a year. This whole theme is one of our popular programs. In the series is robotics. Robotics and AI are going hand in hand. Not obvious, but it is obvious if you think about it, because hardware and software are merging. So talk about why the edge is important, because robots need to have some brains too, right? Or devices, or even any end user experience is going to need a model.
Yeah. There's two parts to the edge capabilities that we are announcing. One is bidirectional streaming support. So this enables real-time communication between both agent to agent and human to agent. And then the other part is going to be more local streaming support. So if you think about a robot in a factory, they can't spend milliseconds waiting for a call to a frontier model in the cloud in order to move the robot arm. So we've seen that our customers in these industrial, manufacturing, autonomous vehicles, all of these industries are increasingly using local models, of course. But they tend to be small. They tend to be not as capable as these frontier models for reasoning and long-range planning. So you get the best of both worlds with this launch because you can run a local model down in the factory floor with Strands, and then you can also run Strands in the cloud where you can access these long-range planning capabilities in the frontier models and combine the two together.
Claire, this comes up a lot around robots because they're getting so much stronger and intelligent, whether they can get more precision on gripping. We're seeing all kinds of use cases, not just the humanoids, everyone thinks humanoids, but just like manufacturing, construction, all these use cases where robotics are really doing well because of the software. So I have to ask, on the model speed, what is the performance threshold? Is there, you mentioned milliseconds. How do you guys view that? Because, I mean, you're driving a car, you can't miss. If it's a self-driving autonomous vehicle or a robo-taxi, everyone kind of sees as an example. But that as that goes to physical world, in the edge, retail, manufacturing, what are some of the performance things that the models need to pay attention to, and how does Strands help that?
Well, we tend to see two different models at play here. One is called VLMs, visual language models, and that's the model that can translate what is this robot sensing with usually a video stream coming in, and how does that turn into what is it seeing? Is it seeing an apple? Is it seeing a car? And then the large language models are really turning that language of all of these inputs that are coming from the real visual world into a plan of action. And then that's going to get turned back into individual motor controls for moving the arms. And so you tend to have these very specialized models for those different tasks locally versus this frontier model in the cloud.
And processing power becomes key, and networking are key elements in the edge.
That's right.
All right, talk about reminders. This came up, you guys are doing reminders. What is that all about?
So we're calling that steering, strand steering, but it's effectively a reminder to the agent. So one of the things with the model-driven approach that we found is that often people want to guide the agent a little bit more in production. As you know, you might test it a couple of times on your laptop. You might test it a few more times before it goes to production, but now you've got thousands of people trying it out. How can you be sure that it's actually following the behavior that you want to give it? One is agent SOPs, which we just open sourced on GitHub, which is a technique that we've been using inside of Amazon to automate work. Agent SOPs is basically a way to structure your prompt to describe the way to accomplish a task. But often, as the conversation gets longer and longer with the agent, we need to give it a little reminder. We need to give it some more steering and ensure that it's staying on task. And so reminders and steering providers, you give it it could be an LLM prompt. It could be just simple code that's validating the agent's behavior. And then you give a little prompt back to the agent that says, hey, you need to be asking about this now, or hey, you should not be doing that task right now.
So it literally is almost like keeping it in its lane.
That's right.
Stay in your lane.
Yeah.
That's interesting. And now, is that like more of a reset, or how does that, because most people think about drift, model drift, and then you kind of have to reprompt. Is that kind of the same concept?
It's more steering it. As you see it kind of drift off, get it to go steer in the other way. And you can hook this into really key lifecycle events. You can hook it into a tool call or a user input response in order to look at, are we still on track with that same agent SOP that I want you to follow? So one example here is something like, you want to build a chatbot that does travel booking, and you want it to gather a certain amount of information from the user, right? Where do you want to go? What day? Often we'll find that a workflow won't work here because it's a conversation. It might go in a lot of different orders of how you collect that information. The user might give you all of the information up front, or they might wait for you to prompt to ask them. And workflows in this case tend to be very brittle for that specific use case because it's a conversation. It could go a million different ways. But steering is able to give the agent a little reminder that says, you're supposed to ask about date. You're supposed to ask about destination before you start go and actually booking something, right? So in
It's
just
a
kind of
QA
validating.
process. It's almost like QA process for the agent. Stay on task and be calibrated.
That's right. Some good feedback for it.
So the TypeScript thing is huge. Looking at the JavaScript, that piece of it, that's going to be a big developer win. Python already is huge there too. Looking at the big picture with TypeScript support, SDK, what's that going to do for the developer? How do you see it fitting in? Does it fit into frontier agents? Where in the Amazon higher level services does it fit? I mean, look at serverless. That came out of internal work, and that just created a whole nother generational shift. Strands, where does Strands fit into kind of the picture?
Strands can be run in Lambda serverless. It can also be run in Bedrock Agent Core runtime. It can take advantage of all of the models within Bedrock, including your own foundational models that you host there. It can take advantage of models that you're hosting in SageMaker. So it has all of those enterprise integrations into the AWS services. But one of the things that I like is that you can also run it anywhere. You can run it on your laptop for testing. You can, now with the TypeScript SDK, you can run it on your website if you want to. So we're really enabling you to run it anywhere that you need to, along with the power that AWS brings with our AI services.
So it's going to bring a lot of user experience, visual, presentation layer capabilities for agents to play with the interactions with users.
Right.
And also make the memes better. They're already crazy right now with the AI. I mean, this is where they're starting to see the fun kick in. For developers, what's the pitch for them? Because this sounds like it's worth investing in. What would you say to the engineers out there and the developers around how to think about Strands, how they should think about the long game of where it goes? What would be your
Well, getting started is very, very easy. We wanted to make it so easy for anybody who is not an AI expert to be able to write an agent in a few lines of code. I've had product managers come to me and say, I wrote a Strands agent and this is amazing. And so not just
I got 5 ideas already I'm going to use it for.
Exactly. And it's really easy to use with your coding assistant. We have tools for your coding assistant that can make it really easy for it to generate an agent for you. So very easy to get started. But we're also doing a lot of experimentation and research on the bounds of agents and pushing the model-driven approach. So the experimental steering capabilities is an example of that, where we're starting to look at how can we push to more and more complex tasks so that it really scales from your first agent to everything that you might want to do in production with agents.
Yeah, and the model-driven approach, you guys have to be sensitive to, okay, let's test the model. Does it fit the parameters of the work of the agent and the tooling around it?
And what we've seen is that actually a lot of models now, including some of the open source smaller ones that are coming out, are very capable for reasoning and planning with Strands, and that's just a drop-in replacement because we have all of this model support already. So I've been playing with GPT OSS 120B on Bedrock, playing with some of the Quen models. So all of those, newer models on Bedrock, we already support on day one.
And with the Nova news, they're going to offer the Amazon proprietary data and allow people to bring their data estate in, have their own frontier model. How does that fit in? Because that's going to be a huge enabler on the enterprise side and startups.
Yeah.
Where you get your, basically for cloud-based pricing, you can have your own frontier model with your data.
Yeah, bringing your data is so important for agents. It's today all that we have is, for most of us, not fine-tuning models. What we have is effectively access to databases and access to knowledge bases. But often you find there's a misalignment between what the model understands, from its training data versus the data that you have, the concepts that you have.
Is there a format that has to be compatible with Strands? Like, for example, does everything have to be a vector embed, or can it just use all unstructured, structured data, or does it have to be formatted?
It doesn't have to be formatted. It can be structured or unstructured. The tool capabilities in Python or in Strands is very flexible flexible. So in Python and in TypeScript, you just write a function and you can do anything you want. You can return structured data, unstructured data, whatever database you need. There's also community tools based around some of the really popular vector databases out there, as well as Bedrock knowledge bases. So all of that information can flow right in. We've got S3 vector support at this point, so you can just put your data in S3 and search it there. So it's easier than ever to access your data from your agents.
Claire, thanks for sharing and unpacking the Strands announcement. Thanks for coming on.
Thanks.
Appreciate it. I'm John Furrier, getting the news and getting a deep dive on what it means and what it means for the future. And again, the developer scenario here is continuing to get better and better with AI and the technology that's enabling better to write the AI native apps, model-driven is a great approach. TypeScript coming in, making it easier for the end user. A lot more value coming. Of course, we're doing our part. Thanks for watching.